I feel good. You feel good? Why? I know. Question number 5. The last sound, right? Right. I understand you feeling good. But I feel good because I'm giving you a very good sum. And there's a lot of depth and reality to it. It's about, how many of you travel by MRT? You do? And going through an underground tunnel? Wow. And this sum refers to that. You see, the earth is excavated to make an underground tunnel for the MRT train. And the tunnel is cylindrical of radius 5 meters. 5 meters, 5 meters, the diameter is 10 meters. Alright, and the length of the tunnel is 0.9 kilometers. And the train has to go through this tunnel for 0.9 kilometers. And you have to find the amount of earth to be removed. Alright, and they want to find and then they said the base of the tunnel is laid with concrete chips at the base of the tunnel to carry the MRT track. They ask you to refer to the diagram. Look at this. All right, refer to the diagram. This is the base, the granite chips. And the line XY, this is the line X, Y, and that's O. They're the radius of this tunnel, of the cross section. And angle XOY, I'm afraid it looks like an acute angle, but it's actually an obtuse angle, 135 degrees. Now they ask you, the first part, what is the volume of earth moved out, removed? Can you tell me what's the volume? It's a cylinder, all right? And what is the volume of a cylinder? The volume of a cylinder equals to pi r squared h. It's a prism with a circular base, area times the height. The area of the base is pi r squared times height. The whole cylinder of earth is taken off. And what is the radius of this? The radius is 5 meters, the height is 0.9 kilometers. So let's put it as pi, r is 5 squared, and h is, change it to meters. That will be multiplied by 1,000, right? Because 1,000 meters make a kilometer. So you get 100. Now 100, okay, look at it, 25 times 9. I just want to look at this here. 25 pi, because this is 25, times 900. Now just out of curiosity, my dear friends, I want to make sure your 25 times table is good. What is 25 times 4? 100, yes. What's 25 times 9? 8 25s make 200. 9 25s is 225, right? 4 25s is 100. 8 25s is 200. 9 25s is 225 pi with a 0, 0. Let's put a 0, 0 first. Pi cm cube. That's the volume of earth dug out. But if you want the exact value, you know that this is about 3. 3 times 225, what do you get? About 707, sorry, it's about 550, 775, if you look at that. So look at it again. So you're going to work it out with the 2 zeros there. 225, 00 times pi. And you get the answer as 70,000. All right, the volume is 70,685.83 cm cube. That's the volume of earth dug out. All right, this is roughly an this is an exact value that I'm giving you. This is an approximation. If you want 3 SF, this is 8 is more than 5. You add 1 over, so that will be equals to, please add 1, you get 70700 cm cube. All right, please take note. That's the volume of earth dug out, 3 SF. 8, 5 more, add 1. And then these two become zeros. So it's 70700 cm cube of earth dug out. Okay? Now, once that part is done, they said that, okay, look at it. The line XY represents, okay, this is the base, and the train is running through that track there. And they said, oi, this is 135 degrees. They want to find the area of the triangle X or Y. Let me get to it right now. B, part 1, the triangle X or Y. This is 5 meters, 135 degrees. Now the area of a triangle is equal to, yep, formula please, everybody. Alright, O, X or Y is half AB sine C. And I think even if you're in secondary 2, it's good to know this formula. Don't get like said, oh, I'm in sec 2, I cannot learn these things. Now you have a calculator, sine is very easily available. Alright, please make sure you get to it. Sec 2, sec 3, sec 4, sec 5. I know sec 2s learn it early. For my center at Clear Minds, we teach them at secondary 2. Alright, so we've got a half, and these are the included sides. And sine 1, the angle here is 135. So it's a half, and these are the sides, included sides, 5 times 5, sine 135. Alright, please work that out. 5 times 5 times sine 125, divide by 2, you get 10.239 cm squared. And that's about 10.2 cm squared. That's the area of triangle XOY. I'm sorry, this should be meter squared, not cm squared. Kumar. Oh. So this is in meters squared, the area of the triangle. Half AB sine C. Half 5 times 5 sine 135, and that would give you 25. Recheck again. You got 25 times sine 135. Work it out. Divide it by 2. Hey, what am I doing? 25 sine 135. Divide by 2. Luckily I checked it. I got 8.8. Let me wear my glasses. Now I get 8.38. What do you get? Do you get the same answer as me? Alright, let me check again. Why did I get that earlier answer? 5, did I press my calculator right? Okay, and then I'm going to multiply by sine 135 and divide it by 2. Thank goodness I checked it. Alright, it should be, it is 8.8388 cm squared. Meter squared. Oh. Alright, and if you get to the nearest 3 SF, you get 84 here, meter squared. Now always, sometimes I may have pressed the wrong angle. It's good to recheck and check, alright, to make sure you're getting it right. Now once you've got that area of triangle X or Y, you're asked to find the volume of the granite used for the whole tunnel. Now you're going to find the area of this segment here, this area of this segment. How do we find out that segment? Alright, we got to find out. Now is the area of this whole sector, minus the area of the triangle will give us this segment. Alright, the area of the whole sector minus the area of the triangle will give us this segment. So let's work that out. We said, okay, area of segment, shaded area, or you can put it as shaded area, shaded region, equals the area of the sector, minus the area of the triangle. And in this case, the sector is this whole thing, the sector of X or Y. And what's the area sector? I've told you all that the area sector, remember this beautiful formula, angle over angle. We take it as 2 pi if you want to take it, and then you can put it as area over pi r squared. You put it that way. Bring the pi r squared up, theta with 2 pi times your pi r squared is the area sector. Cancel, cancel, you get a half r squared theta. But for this condition, your theta must be in radian. Alright, theta must be in radian. And is it a problem? No problem, because we know that 180 degrees is pi. So what is 135? 135 degrees is pi over 180 times 135. Now listen up, pi times 135 over 180, you can see that 45 times table, 45 times 2 is 90, 45 times 4 is 180, 45 times 3, you can see it is 3/4 pi. You see 135 is 3/4 pi. So your area sector is going to be, your theta is going to be a 3/4 pi. Alright, so you can use that concept. Alright, I just want to write this thing. I just wanted to teach you what is area sector. And this is just an reinforcement. I always strongly believe in reinforcing learning. Okay, the area sector, that's one way of doing it. What about the other way of doing the area of sector? You can put your angle over angle, angle over angle, 360 degrees. Area of sector over pi r squared. And what's this angle? The angle is 135 degrees. So you can put, instead of theta, you put 135. And you cancel, you can divide by 45. 45 times 2 is 90. 45 times 3 is 135. So you said A, or 3 times. And how many 90 degrees are there here? In 90 degrees, there are 2 45s, right? Okay, in 360, you can see there are 4 90 degrees. 4 90 degrees means what? 8 45 degrees. We are dividing by 45, 45, you see, we can see it. So this fraction is 3/8 of a circle. The pi r squared can bring up. So you get 3/8, bring the area sector equals to 3/8 of pi r squared. Are you all clear now? And the r here is given to be as 5. So if I look at it, as I said, 3/8 of pi r squared, your r here is 5. You get 25 times 3, 75 pi over 8. Because your r is 5. So you get 75 pi over 8. But let's look at this formula. Does that work it out? Area of sector, if I use this area of sector is half r squared theta. Okay, half r squared theta minus half area of triangle, half AB sine C, area of triangle. You know that your r, alright, is 5. 5 times 5 is 25. Your theta is 3/4 pi. Alright, you can see this part happening. You can see this 75 over 8 pi. Like what I said earlier on. 75 over 8 pi. Alright, like just now we just worked out. 3/8 of pi r squared. R is 5. 25 r squared, 25 times 3, 75 pi over 8. Here, 75 pi over 8. This is the part I know, my dear friends, some of you are struggling. I can feel for you. Those of you who said, I hate maths. Don't. Say, I love it. I remember I went to eat this ice cream at Greenwich. I stay near there. And I went to have this ice cream. They said, what, Cold Stone or whatever this place called. I like it. I love it. I must have it. The 3 portions. I like it. That means small. I love it. Medium. I must have it is the large one. For maths, what must you say? I must have it. Alright, say that. So make maths interesting. Love it. I love it. I must have it. I must know it. Alright, here let's look at it. And the area of the triangle. We worked out the area sector, which is this answer, and the area triangle, we already worked it out here, and we got 8.84, right? So we're going to take this answer and minus 8.84 to get the area of this shaded region. So calculator again. Now 75 times pi divided by 8. Get the answer, you get, and minus, so 75 pi times divide by 8 minus 8.84, and you get 20.612. So the area of sector is going to be area of shaded region. This shaded region, or you call it a segment here, is going to be this answer. Take away this, will give you 20.61. Let me get to the 612 cm. Sorry, why am I saying meters squared? So that's the area of the shaded region. Now once we've got that, we want to find the volume of the granite chips. Remember, my dear friends, this is taking a prism. The prism right here, this is the cross section. And right here, there will be a cross section like that. Hey, cross section like that. And what is the area? The volume of this prism is the area of this cross section times the height. Alright, so the volume of granite is going to be the same as a prism, is the area of the cross section times the height, and that's 20.612 multiplied by the height of this track from one cross section to another cross section, and that height is 0.9 kilometers, which is 900 meters. So you're going to multiply by 900, same units of measurement, and that answer will give you the volume of granite used times 900 will give us 18,551.19. Now you look at it, this is in meter cube. We want, okay, so you read it, is 18,551.19 meter cube. If I want it as 3 SF, this is 5 and above, I just add 1 over, I get 600, 18,600 meter cube. That's the volume of granite used for this track, alright, to make it. Now that answers the volume used. Now we come to a beautiful sum, the last part of it. The MRT train is about 50 meters long. Wow, that's about it. From track to track. You think so? 50 meters long, about there. And they say that the train is traveling at 70 kilometers per hour. 70 kilometers per hour. And find the time taken from entering and finally leaving the track, the tunnel. The track here, I would rather change it. Leaving the track here, I would rather put it as the tunnel. From entering and leaving the tunnel. Alright? So the time, remember, the track is 0.9 kilometers. And the MRT is another 50 meters. It enters in the mouth of it and it has to go through the whole tunnel until the whole back of the track leaves. The back of the train leaves. The whole train should come in and leave. So we got to get that measurement done. How do you find the time? Now, you got to think very carefully. Well, I'm going to erase this part to look at it to get time to do this sum. A really good sum, very relevant to what you've done. All right. Right, let me use a clean to make it cleaner. So you've got the understanding of the whole sum so far, hopefully. You want to find the time, and you're given the speed in kilometers per hour. And we said, oi, what is it? Kilometers per hour. 70 kilometers per hour. That's the speed of the time. So we look at the speed and we said, I don't like a dirty board, so let me do a better job from here. Let me erase a little bit more. Have a clean board. Every time whenever you do your work, make sure your space looks clean, organized. Don't work in an untidy corner. You know what I mean? And it's very, you feel terrible, All right, now let's get some again. The speed of the train is 70 kilometers per hour, but the track itself is 0.9 kilometers. So if you're going to travel 0.9 kilometers, that's the track, plus the 50 meters again. All right, and let's look at the whole thing. We can keep it as it is. The length of the distance traveled will be the track distance plus, you see, this is the train. And the MRT is here. I give a picture, this is the MRT. Entering in, ding ding, until come out here. Right? That means the mouth of the MRT, the starting point is here. The starting point is here. Where's the ending point? The tail must all come out. Everything come out. Ending point is here. Are you all clear? So the length of the distance traveled will be here, which is from here to here 0.9 km, plus the distance, the length of the MRT, which is 50 meters. What is 50 meters? Change it to kilometers. Can you help me? 50 meters is how many kilometers? You know that 1,000 kilometers, how many? Alright, you know that 1,000 meters is 1 km. So 1 meter is 1 over 1,000, right? Km. And 50 kilometers, 50 meters, you multiply that by 50. So you get 1 over 1,000 times 50 km. Dung dung. You get 1 over 20 kilometers. So the distance traveled by the train, will be equal to 0.9, the length of the tunnel, plus 1 over 20. Cancel off. 5 over 100 is 1 over 20. And what is 1 over 20? Please help me. Kilometers. You know that 1 over 2 is 0.5, right? What is 1 over 20? It is 0.05, right? So you add those things, or add 0.9 plus 0.05 will give you 0.95 kilometers. 0.95 kilometers. Now this is the distance. And how long will the train take? Now 1 hour, that is 60 minutes. In 60 minutes, it covers how far? 70 kilometers. Right? You want to find out for 0.95 kilometers that we need to find time, not the distance. So what do we put here? We put here the time will be at the end. 70 kilometers, 60 minutes. Alright, it takes 60 minutes. 0.95 kilometers, how long do you take? 60 divided by 70 times 0.95. That will give you the answer. 60 divided by 70 is 6 over 7. So you get 6 times 0.95 divided by 7. And you get 0.81. You get 0.814 minutes. Alright, 0.814. If I were to change it to seconds, I multiply it by 60 again, and I get 48.854 seconds, which is equal to 48.85, that means 0.9 seconds. Well, that's a really good sum. Alright, a real good sum. Well, if you look at it, the MRT train is 50 meters. The length of the track is 0.9 km. Add the total distance, 0.9 plus 0.05. Going to change this. That's the length that the train, the time, is going to travel that distance. 70 kilometers in 1 hour. That's 60 minutes. So how long does it take 0.95 kilometers? You divide by 70, multiply by 0.95, you get 0.814 minutes, which is 48.9 seconds. Wow! Sometimes when you do a song, they say, woo, you feel good. We say in Hindustani, kush kush hota hai. Small things that tickle my heart. What again? Small things that tickle my heart. Now, I hope you understood the topic on volume. I love this song so much, MRT train. You're asked to find, read through, run through again, and you will be there to find from the area to volume of the granite used and write down the time taken. Run through slowly again. This is a real good chapter and you'll be a master of areas and volume. Take care. Have a great day. I salute you for being attentive. Goodbye.